For millennia, humanity has been captivated by the warm, radiant luster of gold. It has been the measure of kings, the foundation of empires, and the ultimate symbol of wealth and power. Yet, for all its perceived value, gold is surprisingly abundant when compared to some of the true rarities our planet, and indeed, the universe, has to offer. The Earth holds secrets in its deepest recesses, treasures hidden in plain sight, and materials so fleeting they exist for mere moments. These are substances born from cosmic fire, geological pressure, or the strange and wonderful processes of life itself. Hidden away in sun-scorched deserts, buried miles beneath the surface, and even flowing within the veins of living creatures are substances of almost unimaginable scarcity. A single gram of some of these materials can command a price that would dwarf a lifetime's supply of gold, their value derived not just from their rarity, but from their extraordinary properties and the unique roles they play in science, medicine, and culture. They are the building blocks of the future and the remnants of a primordial past, each with a story as remarkable as its price tag. Join me as we embark on a journey to uncover these hidden treasures. We will explore the frontiers of physics to witness the most expensive substance known to science, delve into the Earth's crust to find gemstones rarer than any diamond, and sail the oceans in search of a fragrant excretion worth a fortune. From deadly venoms and cosmic elements to luxurious spices and metals forged in the hearts of dying stars, here are 15 natural substances that are, gram for gram, far more valuable than gold. Our journey begins not on Earth, but at the very edge of our understanding of the cosmos. Here we encounter a substance so ephemeral, so contrary to our everyday reality, that its existence seems like science fiction. This is antimatter. For every particle of matter, like the protons and electrons that make up you and me, there exists an antiparticle, a mirror image with an opposite charge. When matter and antimatter meet, they annihilate one another in a burst of pure energy, the most efficient energy release known to physics. It is the perfect fuel, but there is a profound catch. The universe, for reasons we do not yet fully comprehend, has a distinct preference for matter. Antimatter is almost nowhere to be found naturally. To study it, scientists must create it, a process of immense difficulty and staggering cost. Inside colossal machines like the Large Hadron Collider at CERN, physicists accelerate particles to near the speed of light and smash them together. In the fleeting, high-energy aftermath of these collisions, a handful of antiparticles can be coaxed into existence, only to be immediately captured by powerful magnetic fields before they can touch the walls of their container and vanish. The sheer energy required to produce even a nanogram, combined with the technological sophistication of the process, makes antimatter the most expensive substance ever created. The cost to produce a single gram is estimated to be in the quadrillions of dollars, a figure so vast it is almost meaningless. It represents the absolute pinnacle of value, a substance whose price reflects the very limits of human ingenuity and our quest to understand the fundamental laws of the universe. For now, it remains a scientific curiosity, a glimpse into a world of physics that is the perfect and impossibly valuable opposite of our own. Deep within the controlled and shielded heart of a nuclear reactor, a modern form of alchemy takes place. Here, scientists create elements that do not exist in nature, forging them atom by atom. One of the most remarkable of these is californium-252. Discovered in 1950 at the University of California, Berkeley, from which it gets its name, this radioactive isotope is one of the heaviest and most complex elements ever produced. Its creation is a long and arduous process, requiring years of neutron irradiation inside a specialized high-flux reactor. What makes californium-252 so exceptionally valuable is its unique property as an incredibly potent neutron source. A single microgram of this substance emits an astonishing 170 million neutrons per minute. This intense stream of particles makes it invaluable for a range of highly specific and critical applications. It is used to kickstart nuclear reactors, providing the initial neutrons needed to begin a chain reaction. In medicine, its precision allows it to be used in certain forms of radiotherapy, targeting and destroying cancer cells with focused neutron beams. It is also used in devices that scan for precious metals, oil, and water deep underground. The world's entire supply of californium-252, produced almost exclusively in the United States and Russia, amounts to only a few grams. The intricate and dangerous production process, coupled with its critical applications, places its value at an estimated $27 million per gram. It is a substance born of nuclear fire, a testament to our ability to manipulate the very building blocks of the universe, and a tool that, despite its immense cost, holds the key to powering our world and healing our bodies. In the mineral-rich soils of Myanmar, a land renowned for its extraordinary gemstones, a British mineralogist named Arthur C.D. Payne made a discovery in the 1950s. He found a strange, dark, reddish-brown hexagonal crystal that he initially mistook for a ruby. For decades, this single specimen, and one other found later, were the only known examples of this new mineral in the world. It was named Paynite in his honor, and for nearly half a century, it held the title of the world's rarest gemstone, a mineralogical ghost. The extreme rarity of paynite is due to its unique chemical makeup. It contains calcium, zirconium, boron, aluminum, and oxygen. Zirconium and boron are elements that very rarely associate with each other in nature, making the geological conditions required for paynite to form almost impossibly specific. It was as if nature had conducted a 1 in a billion experiment, and for years it seemed it had only succeeded twice. Finding a new crystal of paynite was considered a monumental event in the world of gemology. In the early 2000s, new deposits were finally located in Myanmar, increasing the number of known crystals from a handful to several thousand. However, the vast majority of these are small, heavily included, and not of gem quality. Faceable, high-quality paynite remains one of the holy grails for gem collectors. A single carat can be valued at over $60,000. It is a stone born from a geological fluke, a beautiful accident of chemistry that reminds us that even after centuries of exploration, the Earth still holds its most precious secrets close. The world of gemstones is, just full of stories of chance and discovery, but honestly, few are as serendipitous as that of Tawhid. Back in 1945, the Irish-Austrian gemologist Count Edward Charles Richard Tawhid was sorting through a parcel of what he believed were just ordinary Sri Lankan spinels. But then, one particular mauve-colored stone really caught his eye. It exhibited a property that spinel does not: double refraction. Intrigued by this anomaly, he decided to send the stone to a laboratory for analysis, which, confirmed his suspicion. He had not found a flawed spinel, but an entirely new, unrecognized mineral species. This method of discovery, from an already cut and polished gemstone rather than a rough crystal in a mine, is honestly exceptionally unusual. Tawhid had been hiding in plain sight for years, mistaken for its more common cousin, spinel, just because of their similar appearance. The key difference lies in its chemical composition. Tawhid contains beryllium, which really sets it apart. It is one of the very few minerals to be discovered as a faceted gem, a testament to the keen eye of a single individual. To this day, Tawhid remains one of the world's rarest and most coveted gemstones. It is estimated to be over 1,000,000 times rarer than diamond. Found primarily in Sri Lanka and Tanzania, only a small number of these stones have ever been found, and the total known quantity would barely fill half a teacup. Its subtle and beautiful range of colors, from mauve and lilac to pink and near colorless, makes it highly desirable for collectors and connoisseurs of fine jewelry. With prices reaching up to $35,000 per carat, this accidental discovery is, well, a treasure born from a moment of careful observation. The diamond, a symbol of endurance and love, is perhaps the most famous gemstone on Earth. Forged from carbon under immense pressure and heat, deep within the Earth's mantle, its journey to the surface is a violent and, honestly, ancient one. While a high-quality white diamond is certainly valuable, its worth is dwarfed by its far rarer and more spectacular siblings, the fancy-colored diamonds. These are the true aristocrats of the diamond world, stones whose value really transcends the standard metrics of cut, clarity, and carat. The vast majority of diamonds fall within a color range from colorless to light yellow or brown. But on very rare occasions, other elements become trapped within the crystal lattice as it forms, or the lattice itself becomes distorted. These geological anomalies can produce breathtaking hues of blue, green, pink, red, and orange. Nitrogen atoms can create yellow, boron can impart a stunning blue, and natural radiation can turn a diamond green. The origin of pink and red diamonds, the rarest of all, is still a matter of scientific debate, but is thought to be caused by immense pressure distorting the crystal structure. These colored diamonds are so rare that for every 10,000 carats of white diamonds mined, only 1 carat of colored diamonds is typically found. A flawless, vivid blue or pink diamond can command prices of over $1,000,000 per carat at auction, making them some of the most concentrated forms of wealth on the planet. They are not just gemstones. They are geological miracles, tiny prisms that have captured a fleeting, colorful moment from the Earth's violent creation, making them infinitely more precious than their colorless counterparts. We return now to the world of atomic science, to an element synonymous with immense power and profound danger, plutonium. Like californium, plutonium is a transuranic element, virtually non-existent in nature and produced almost exclusively within nuclear reactors. It is formed when the nucleus of a uranium-238 atom, the most common isotope of uranium, absorbs a neutron, setting off a chain of radioactive decay that transforms it into plutonium. This process is, honestly, a cornerstone of nuclear technology. Plutonium's value lies in its fissile nature. Certain isotopes, particularly plutonium-239, can sustain a nuclear chain reaction, releasing enormous amounts of energy. This property makes it a primary fuel for a new generation of nuclear power plants, known as fast breeder reactors, which can generate more fuel than they consume. However, this same property also makes it the key ingredient in modern nuclear weapons. A sphere of plutonium no larger than a grapefruit is sufficient to create a devastating explosion, a fact that has shaped global politics for over 70 years. Because of its dual use, plutonium is one of the most heavily controlled and regulated substances on Earth. Its production, handling, and transport are governed by international treaties and stringent security protocols. It cannot be bought on any open market. Its official value is often cited at around $4,000 per gram, but this price is purely theoretical. Its true value is strategic, a measure of national power and technological prowess. It is an element of paradox, a potential source of limitless clean energy, and a tool of unimaginable destruction. In the darkness, a faint, steady glow emanates without any source of power. This is the work of tritium, a radioactive isotope of hydrogen. While a normal hydrogen atom has a single proton in its nucleus, and deuterium has a proton and a neutron, tritium possesses a proton and two neutrons. This configuration makes it unstable, and as it decays, it releases low-energy beta particles. When these particles strike a phosphor material, they cause it to fluoresce, creating a continuous, self-powered light that can last for more than a decade. This unique property makes tritium incredibly useful. It is the glowing heart of emergency exit signs that require no electricity, the luminescent markers on high-end watch dials and gun sights that allow them to be seen in complete darkness. In scientific research, it is used as a radioactive tracer to study metabolic processes. And looking to the future, it is a key fuel component, alongside deuterium, for experimental nuclear fusion reactors like ITER, which aim to replicate the power of the sun here on Earth. Despite being an isotope of the most abundant element in the universe, tritium is exceptionally rare and expensive to produce. It is generated in small quantities within nuclear reactors or by bombarding lithium with neutrons. The global supply is tightly controlled and measured in mere kilograms. This scarcity, combined with its high demand in commercial, military, and scientific fields, pushes its price to an astonishing $30,000 per gram. It is a substance that literally brings light to the darkness, a tiny glowing beacon powered by the slow, inexorable process of atomic decay. In the realm of precious metals, gold, silver, and platinum often take the spotlight. But there is another, far rarer, and often more valuable member of the platinum group, rhodium. This silvery white, hard, and corrosion-resistant metal is one of the noblest of the noble metals, meaning it is exceptionally resistant to oxidation and acid attack. It is so inert and reflective that it is often used to plate other precious metals, like white gold or sterling silver, to give them a brilliant tarnish-proof finish. However, rhodium's primary and most vital application lies hidden beneath our cars. Over 80% of the world's rhodium supply is used in the manufacturing of catalytic converters. Inside this device, a honeycomb structure coated with a thin layer of rhodium, platinum, and palladium acts as a powerful catalyst. As harmful exhaust gases like nitrogen oxides pass over it, the rhodium helps to convert them into harmless nitrogen gas. It plays a silent but crucial role in reducing air pollution from millions of vehicles every day. Rhodium is incredibly scarce, with annual production being only a tiny fraction of that of gold or platinum. It is found in minute quantities alongside platinum deposits, primarily in South Africa and Russia. This rarity, combined with its indispensable role in the automotive industry, makes its price notoriously volatile. It can swing wildly based on supply disruptions, new emissions, regulations, and industrial demand, sometimes skyrocketing to over $20,000 per gram, many times the price of gold. It is a silent hero of our modern world, a rare metal that helps us breathe cleaner air. We have already encountered the element plutonium, but it is a specific isotope, plutonium-239, that holds the most profound significance for human history. This particular arrangement of 94 protons and 145 neutrons is the primary fissile isotope used in the production of nuclear weapons. Its nucleus is uniquely unstable and, when struck by a neutron, can split apart in a process called fission, releasing a tremendous amount of energy and more neutrons, which in turn can split other plutonium-239 atoms, creating a devastatingly powerful chain reaction. The production of plutonium-239 is a deliberate and complex process. It is bred inside nuclear reactors by irradiating uranium-238. After the fuel has been used, it undergoes a highly dangerous and technically demanding process called reprocessing to chemically separate the small amount of plutonium-239 from the unspent uranium and other highly radioactive fission products. This weapons-grade material is the very heart of a modern nuclear warhead, the substance that gives it its terrifying power. Like all plutonium, plutonium-239 is not available for private purchase. Its possession is restricted to a handful of nations under the strictest security imaginable. While its official price is often quoted in the range of $5,000 to $6,000 per gram, this is a purely academic figure. Its true worth is geopolitical. The ability to produce and weaponize plutonium-239 represents a nation's entry into the nuclear club, a capability that fundamentally alters the balance of global power. It is a material whose value is not measured in currency, but in its potential to shape the destiny of nations. The beryl family of minerals gives us some of the world's most beloved gemstones. With just a trace of chromium, it becomes the lush green emerald, and with iron, the serene blue aquamarine. But, when a whisper of manganese finds its way into the crystal structure, it creates something far rarer, and, to many collectors, far more desirable. Red beryl. Sometimes marketed as the Red Emerald or Scarlet Emerald, this name, while evocative, doesn't really do justice to its profound rarity. It's a gem in a class all its own. Red beryl is found in only one location on Earth where gem-quality crystals are produced. The ruby violet claims in the Wawa Mountains of Utah, USA. The geological conditions required for its formation, the right combination of beryllium, aluminum, silicon, manganese, and a specific volcanic rhyolite host rock, are so exceptionally precise that they have occurred nowhere else in a way that yields faceable material. For every 150,000 diamonds mined, only one crystal of red beryl is found. Most red beryl crystals are really small, with faceted stones over 1 carat being exceptionally rare and highly prized. The intense raspberry red hue is entirely natural, requiring no heat treatment to enhance its color. This combination of spectacular color and extreme rarity makes it one of the most sought-after gems for collectors. Fine specimens can command prices upwards of $10,000 per carat, making this American treasure significantly more valuable than most of its more famous beryl cousins, and a true testament to the unique geological wonders hidden within our planet. Our journey takes us now to the great island of Madagascar, a hotspot of biodiversity and, honestly, some pretty unique geology. It was here, in the southern part of the island, that French mineralogist Alfred Lacroix first discovered a remarkable new mineral back in 1902. He named it Grandidierite, in honor of the French explorer and naturalist Alfred Grandidier, who had extensively studied the island. The mineral he found possessed a beautiful and unusual bluish-green color, a hue that's rarely seen in the gem world. What makes Grandidierite so special is its strong pleochroism. This means it can actually appear to be different colors, typically blue, green, and white, when viewed from different angles. This trichroic quality gives the stone a captivating, shifting inner life. For much of the 20th century, Grandidierite was known only from a few small, translucent to opaque specimens. It was considered a mineralogical curiosity, impossibly rare and, honestly, of little interest to the gem trade. Gem-quality, transparent material was thought to be non-existent. That all changed in the year 2000, when a new deposit was discovered near the village of Tranamaro in southern Madagascar. For the first time, transparent, faceable crystals were unearthed. A second, even more significant find occurred in 2014, finally bringing enough material to the market for it to be recognized by fine jewelry connoisseurs. Still, it remains one of the 10 rarest gemstones on the planet. With prices for clean, transparent stones reaching as high as $20,000 per carat, this once obscure Malagasy mineral has taken its rightful place among the world's most valuable gems. For centuries, strange waxy lumps have washed ashore on beaches around the world. their origin a complete mystery. Known as ambergris, this substance was as valuable as gold, yet no one knew where it came from. Some thought it was hardened sea foam, others a type of marine fungus. The truth, discovered only with the advent of modern whaling, is far stranger. Ambergris is a pathological secretion, a kind of intestinal stone, formed in the digestive system of the mighty sperm whale. It's believed that ambergris is produced to protect the whale's intestines from the sharp, indigestible beaks of the squid and cuttlefish upon which it preys. The whale eventually regurgitates this mass, or expels it, and it floats upon the ocean currents. Initially, it's a foul-smelling, dark, soft mass. But over years, sometimes decades, of exposure to sun, salt, and sea, it undergoes a remarkable transformation. It hardens, lightens in color to gray or white, and develops a complex, sweet, earthy, and marine-like aroma that is utterly unique. This unique scent profile makes aged ambergris one of the most prized and valuable ingredients in high-end perfumery. It's not used for its own scent, but as a fixative. A tiny amount added to a perfume allows the fragrance to bind to the skin and last for hours, its own subtle aroma adding a layer of indescribable depth and richness. Because it is found, not harvested, its discovery is a matter of pure chance. A single, well-cured lump can be worth a fortune, with prices reaching up to $25,000 per kilogram. It is floating gold, a strange and fragrant gift from the largest toothed predator on Earth. In the damp autumn soils of the Piedmont region of Italy, a select group of hunters and their specially trained dogs embark on a secretive quest. They're not searching for game, but for a fungus, a subterranean treasure known as the Alba white truffle. Unlike their black truffle cousins, the white truffle has resisted all attempts at cultivation. It grows only in the wild, in a symbiotic relationship with the roots of specific trees like oak, hazel, and poplar, and its location is a closely guarded secret passed down through generations. The value of the white truffle lies entirely in its explosive and complex aroma. It's a scent that really defies simple description. A heady, intoxicating mix of garlic, aged cheese, damp earth, and something else. Something musky and ethereal that has captivated gourmands for centuries. This aroma is incredibly volatile. From the moment it's unearthed, its power begins to fade. It can't be cooked, as heat would destroy its delicate fragrance. Instead, it's shaved paper-thin over pasta, risotto, or eggs, its scent blooming in the steam of the hot food. The combination of extreme rarity, the inability to be cultivated, and its fleeting, magical aroma makes the white truffle one of the most expensive food items in the world. Its price is dictated by the season's harvest, fluctuating wildly based on weather and demand. A good quality white truffle can easily fetch over $4,000 per kilogram, with exceptionally large specimens selling for hundreds of thousands of dollars at auction. It's not merely food, it is an experience, a momentary and unforgettable taste of the rich, hidden life of the forest floor. In fields across Iran, Spain, and Kashmir, a sea of purple flowers blooms for just a few short weeks each autumn. This is the Crocus sativus, the source of the world's most expensive spice by weight saffron. The value of this spice isn't in the flower itself, but in the 3 tiny crimson threads that lie within. These are the stigmas, the female part of the flower, and they must be harvested by hand, a task of immense patience and delicacy. The harvest is a race against time. The flowers have to be picked at dawn, before the heat of the day can cause them to wilt and damage the precious stigmas inside. Once picked, the painstaking work continues, as each individual stigma is carefully plucked from the flower, again by hand. It takes an astonishing number of flowers, somewhere between 75,000 and 150,000, to produce just 1 kilogram of dried saffron. The land and labor required for such a tiny yield is what underpins its extraordinary cost. For millennia, saffron has been treasured not just for its subtle, hay-like flavor and the brilliant golden yellow hue it imparts to food, but also for its use in traditional medicine and dyes. It's the heart of dishes like Spanish paella, Italian risotto Milanese, and Persian rice. A small pinch is all that's needed to transform a dish. Depending on its quality and origin, a kilogram of high-grade saffron can cost anywhere from $2,000 to $10,000, earning it the well-deserved title of red gold. It's a spice born of painstaking human effort, a vibrant thread connecting us to ancient culinary traditions. In the jungles of Southeast Asia, the Aquilaria tree grows. In its healthy state, the wood is pale, light, and odorless. But when the tree is injured, maybe by a lightning strike, an insect boring into its trunk, or a fungal infection, it responds with a remarkable defense mechanism. It produces a dark, dense, and intensely aromatic resin to protect itself and heal the wound. This resin-impregnated heartwood is known as agar wood, or oud, and it's one of the most valuable raw materials in the world. This process of formation is rare and unpredictable. Only a small percentage of Aquilaria trees will ever produce agar wood, and it can take many decades, even centuries, for the resin to fully develop. For generations, collectors would search the forests for naturally infected trees, a difficult and often fruitless task. The scent of agar wood is incredibly complex, with notes of wood, smoke, balsam, and sweet amber. It's deeply ingrained in the cultural and religious traditions of the Middle East and Asia, burned as incense in sacred ceremonies, and used in traditional medicine. The highest quality agar wood, known as kainam or kiara, is so rare that it's worth more than its weight in gold many times over. The demand for this fragrant wood has driven the wild Aquilaria tree to the brink of extinction, making it a CITES-protected species. Today, much of the agar wood on the market comes from cultivated trees that have been artificially inoculated to stimulate resin production. Even so, the price for high-grade, naturally formed agar wood can exceed $100,000 per kilogram, making it a substance whose heavenly scent is matched only by its astronomical price. Our journey has taken us from the heart of the atom to the depths of the ocean, from the sterile confines of a laboratory to the rich soil of an ancient forest. We've seen that the gleam of gold, so long our benchmark for wealth, pales in comparison to the true rarities our world has to offer. The value of these 15 substances is a complex tapestry woven from threads of scarcity, difficulty of production, unique utility, and deep cultural significance. They are the pinnacle of what is rare, the very definition of precious. These materials challenge our perception of worth. Is value measured in the power of a fissile isotope that can shape the fate of nations? Or in the fleeting aroma of a subterranean fungus that brings a moment of pure culinary bliss? Is it found in a gemstone's impossible color, born from a geological accident billions of years ago? Or in the fragrant resin produced by a dying tree? Each substance tells a story, a narrative of cosmic chance, biological wonder, or human ingenuity pushing the very boundaries of what is possible. As we continue to explore our planet and the universe beyond, we'll undoubtedly uncover new materials with properties and potential we can currently only dream of. The quest for what is rare and valuable is a fundamental part of the human spirit, driving us to dig deeper, look closer, and reach further. For in the end, the true measure of value is not simply a price tag, but the story a substance tells, and the new possibilities it unlocks for all of us.